This is Professor B here, and we are going to talk about condensing logarithms today. So in a previous video, I showed you guys how to expand logarithms. You've got one logarithm, you break it into a bunch of different ones. We're going to backtrack that now, okay? We're just going to go backwards. We're going to start with a bunch of logarithms. We're going to go down to one, all right? So before we do that, again, this is condensing. We're going to condense everything down. The way you know you're done is when you are down to one single logarithm. Okay, we use this mostly when we are solving logarithms and we are just trying to simplify as much as possible. Okay, so before we get to some spicy examples, we are going to go through our properties again, but I'm just going to show the properties to you backwards. Okay, so if we take a look at the first property, remember this first property, this is called the product. Okay, this is the product property. The reason being product is, remember, you've got multiplication here. Okay, so when we were expanding, we started off with one logarithm, we broke it into the two. Now we're going to go backwards. We're starting with these two logarithms and we're going to condense it to one. The things you want to look for are, you want to look for an addition sign. When you see that addition sign, that means you are going to multiply your arguments. Okay, so what we are going to do for this is, again, kind of a formula if you want to follow. This is our mild example. We have the log base 7 of 2 plus the log base 7 of x. Notice that the bases are the same. You want your bases to be the same. If your bases are not the same, you cannot use this property. Okay, so our bases are the same. So we have an addition sign. I'm going to do it that way. I'm going to do it this way. I have an addition sign. That means I am going to take this logarithm argument, and I'm going to take this argument, and I'm going to multiply them together. Okay. So in the end, I'm going to end up with log base 7, base stays the same, do not multiply your bases, of 2 times x. And I'm done. I combined both of these logarithms into one. Okay, the addition sign is your red flag to multiply your arguments. Okay, the next rule that we talked about, this is the quotient rule. All right, so we talked about how if you're dividing in your argument, you break that apart into two logarithms with subtraction. So going backwards now, we are subtracting our logarithms. Again, the bases are the same. So that means you will divide your arguments. Quotient. Okay. It is always going to be the first argument divided by the second argument. So your first argument is going to go on top of your fraction if you're writing it that way. All right. So we look at our example here. I have 3 as my base. 3 is my base. That's a good start. We have to have the same base. And then we have a subtraction sign. That means I am going to take this argument right here and this argument right here, and I am going to divide them. The x will go on top since it came first. So my ending answer would be the log base 3. Again, you don't mess with your bases. Once it's 3, it stays 3, of x over 5. Okay, so subtraction means divide your argument. And there's my ending for that mild example. Okay, the last property that we're going to talk about for this condensing idea is the power rule. This is the power rule right here. Okay, that means that if there are any factors out in front, again, when we did it for expanding, we took the power and we pulled it out in front. Now we're just going backwards. We have any factors out in front, those are going to get pushed up into the exponent. So you're looking at it going from this way. This turns into this. Okay, factors become powers. Factors become powers. All right, so for our mild example, we have 3 times the log of x. The 3 is a factor. It is multiplying times the whole logarithm. So it is going to come out to be a power. And our ending answer would look like this. It would be the log. Again, we don't see a base, so it's an understood 10. So we have the log of x to the 3rd power. And that would be our ending answer for that. Okay? So you're just taking everything we did. If you followed along with the expanding video, we're going to do that backwards. Okay? Let's take a look at a medium and spicy example now. Okay? So here is our medium example. Instructions, we are going to condense the following to a single logarithm. So we know we're done when we are down to 1 logarithm. Okay? Much like with the expanding, I wrote an order of operations over here to the side for you. Notice it's just the reverse of what we did. So now we're going to do power, product, and then quotient at the end. Okay, so power rule first. All right, so I'm going to look through. There's no power rule here. I don't have anything out in front multiplying. But I do have a power rule here because I have this 2. So I'm going to push this 2 to be an exponent. So I'm going to rewrite the first logarithm because nothing changed, so I'm not going to change it. Plus, I'm going to move that 2 to be an exponent. So now I have the log base 3 of y squared. Okay, so that was my power rule. Next, what I'm going to do is I am going to see if there is a product rule that I can use. So I did the power rule. Now I'm going to look for a product. I do see a product because I see an addition sign. Addition sign means I am going to take this argument and this argument, and I am going to multiply them together to make 1 logarithm. So the log and the base stay the same. So this is going to be the log base 3 still, but I'm going to multiply my x and my y squared. So this is going to become x, y squared. Okay. And then last but not least, I checked there's a power rule, I did it, a product rule, I did it. I'm going to check and see if there's a quotient rule. There is nothing else. I am down to 1 logarithm, so there's no quotient rule I need to worry about. So I am going to be done. I've done 1 logarithm. Okay? All right. So again, just like with the expanding, the only time these problems get spicy is when it comes down to the rules of exponents, the algebra, that's the area, okay? This part is all going to stay the same. We're going to do power, product, quotient over and over and over again. And then it's just that the argument is going to look messy until you fix it either with rules of exponents or with your algebra skills, okay? So don't be afraid of the spicy ones. The process is going to stay the same. We just got to go backwards and remember our exponents and our algebra. So first thing I'm going to do is my power rule. Remember? Power. So I'm going to look through each logarithm and see if there's a power I can handle. It looks like, oh, look, I see a power first thing. So remember, that is going to come out in front. I'm going to go ahead and check and see if there's any other powers that I deal with. Nothing there, so no power there. And nothing there, so no power there. So that's my only power rule. So I'm going to rewrite that as the log base 4, bases stay the same, of a to the 3rd power. And then I am going to copy everything else so that I don't lose anything. Okay? So that took care of my power rule. Check. Next, I'm going to look for product rule. Product rule is addition sign, okay? So I'm going to look for an addition sign to use my product rule, just like you would look for a subtraction sign to use your quotient rule, okay, for condensing. So I don't see any addition signs, so that means that there's no product, so check. I've done my power, I've done my product. Last but not least, I've got quotient, and I've got two subtraction signs here. We're going to take them one piece at a time. We're not going to try and do everything at once, all right? So the first thing that I'm going to do is I see this subtraction sign. That means, remember, you are going to take the argument here and the argument here, and you will divide, okay? So I'm leaving this part alone right now. I am not going to try to take a bigger bite than I can chew. I want to keep this one piece at a time. So I'm going to write this as, again, 1 logarithm, log base 4, base stayed the same, first divided by second. Okay, so that means that I'm going to have a to the third divided by 7 minus log base 4 of b. Okay, we took one bite at a time. So we handled these two logarithms first, and now we're going to deal with this third one. Okay, so now we go, oh no, I've got another subtraction sign. So we're going to do the exact same thing. We're going to do the quotient rule all over again because it's subtraction. So we're going to take this argument, and we're going to take this argument, and we are still going to divide them. Just because you use the quotient rule once doesn't mean you can't use it again. Same goes for the power, same goes for the product. So my log base all stays the same. Remember, log base 4. And now I'm going to have this really, it's going to look ugly. Don't panic. A cubed over 7 over b. That's really gross looking, right? This is what makes this problem spicy, because hopefully you guys can see, okay, she did the power, she did the quotient rule once, and then did the quotient rule again. So here's what makes this problem spicy. You have to clean this up, all right? So if you remember how to clean up complex fractions, yay, that's exactly what we're going to do. If you don't, go check out my video on complex fractions. I show you exactly how to take care of this. Okay, so what we're going to do is I'm going to come over here and I am going to break this complex fraction, because you've got a fraction within a fraction, and I'm going to break it apart. So I'm going to break apart the top two, and then I'm going to break apart the b. All right, so when I do that, I'm going to get a cubed over 7 divided by, remember a fraction bar is division, my b, and then just so it's a fraction too, I'm going to put it over 1. Any whole number can be put over 1 and it's a fraction. All right, so next what we're going to do, again, dividing fractions, we multiply by reciprocals, so this is going to be a cubed over 7. This is going to turn into a multiplication symbol, and then I am going to flip my second fraction. We are multiplying by reciprocal. So this is going to end up being 1 over b. And then we multiply straight across. So this is a cubed times 1, which is a cubed, over 7 times b, which is which is 7b. And this is my simplified complex fraction. So this is the same as this, just cleaned up. All right, and so our ending answer for our logarithm is going to be log base 4, again, I'm keeping the base the same, of my simplified fraction, which is a cubed over 7b. And there is my ending answer for my spicy problem. Okay, please don't let long, complicated monster problems become that monster. All right, we are going to take this a one bite at a time. We don't want math to get hard for ourselves, right? Math can be hard all by itself. We don't need to help it. We just want to take it a bite at a time. All right. If you've got any other questions over condensing or expanding logarithms, if you've got anything you want to talk about, leave a comment down at the bottom. I'd be happy to do more examples. Like the video. Let me know what you guys need, and I will see you next time in class. Bye.